dealing with Cartesian coordinate systems. Okay, so Cartesian coordinate system involves two axes. So let me draw two axes. One is vertical axis, which is also known as y-axis, and the other one is the horizontal axis known as x-axis. And this system is known as Cartesian coordinate system in honor of a French mathematician, René Descartes. So René Descartes introduced this system. So in honor of him, this is known as Cartesian coordinate system. Okay. Coordinate means the location of a point with respect to a reference point. And in this Cartesian coordinate system, the reference point is taken as to be the origin. And the origin's location is 0, 0. Okay. Now let's take any one point, let's say the point to be P. The distance of this point from the x-axis is x, and the distance of this point from the y-axis is small y. Okay, then the coordinate of this point will be given by x, y. Okay, so this is how we represent different points in the Cartesian coordinate system. So one more thing, this distance x is known as the abscissa. The distance y from the y-axis is known as ordinate. Okay, so any point is given by abscissa and ordinate. These two represent the coordinates of a point. Now we'll see distance between 2 points. As you all have already studied in high school about the distance formula. I will give a recap to that. If there are 2 points, let's say A and B, okay, the coordinates of A are x1 and y1, coordinates of B are x2 and y2, and we need to find out the distance between A and B, that is AB. Then according to the distance formula, this distance is given by AB is equals to square root of y2 minus y1 squared plus x2 minus x1 squared. Okay, so it's basically the square root of difference of ordinates squared plus difference of abscissas squared, right? So this is the distance formula. After the distance formula, we'll move on to section formula. Okay, so the distance formula is, let me rewrite it. Distance formula is AB, that is the distance between the points A and B, the square root of x2 minus x1 squared plus y2 minus y1 squared. Now we move on to the sections formula. Sections formula tells us how a point divides a line in two halves, okay, into two parts. That would be correct to say. See, x, y. There is a point P with the coordinates x, y that divides a line joining point A and point B with coordinates x1, y1 and x2, y2 respectively in the ratio m is to n. That is, AP by BP is equal to m by n. This will be given. The ratio m is to n will be given. right? Suppose it would be 2:1, then it will be given that m/n is 2:1. It will be mentioned in the question. Okay, example. Okay, now given this information, you need to find out the coordinates of that point pxy, x comma y, that divides this line AB in the ratio m/n. So to do that, we use section formula, that is given by x is equals to mx1 plus mx2 by m plus n, and y is equals to my1 plus ny2 divided by m plus n. Now, as you can see that this point P divides the line AB internally. So this point is within the line AB and it divides this line internally in the ratio m/n. Now let's see, this is internal division. This is internal division. Now let's look at external division. Okay, in external division, the same point lies outside the line. Let's see how the point will divide the line now. Let's see that. So here is the line A, B, x1, y1 and x2, y2. There's one point that is P, x comma y. Now this divides this line in the ratio AP m is to BP, right? AP by BP is equals to m by n. This is known as external division. Okay, now the coordinates will be given as x equals to m x2 minus n x1 by m minus n. Y will be given as my2 minus ny1 by m minus n. So this is the section formula. So let me summarize it as follows. Internal division, the point is given as, coordinates are given as mx1 plus mx2 by m plus n, comma my1 plus ny2 by m plus n, and for external division, the coordinates are given as p equals to m x2 minus nx1 by m minus n and m y2 minus ny1 by m minus n. So you should note this down, right? You should note all these formulae down. These are very important and the questions come from these. Okay. Now let's take a special case for internal division. Let's say there's a point which divides a line joining A and B into two equal halves. Okay. This point divides these line joining these 2 points into equal halves. What do I mean? It means m is to n is 1:1. It means m is and n are equal. It means AP and BP are equal halves. Now the coordinates simplify to, you can see you can put m and n as 1. So m is 1, n is 1. You can pick m and n as 1 in the internal division formula. Then you will get x1 plus x2 by 2, y1 plus y2 by 2. This point P is known as the midpoint of the line. Midpoint. Okay, midpoint of AB. So this is a formula that is derived from the internal division section formula. Okay. Now let's look at triangles. We'll see area of triangles and we'll look at some properties of the triangle that are generally useful in questions in JEE. So let's start from the very basic. We'll see area of a triangle. Okay, so let me draw triangle first. Here is the triangle. Wait, yeah, this is the triangle A, B, and C. So let's say let's name it from here A, B, C. Let's say this is x1, y1, this is x2, y2, this is x3, y3. We know the coordinates of all the corners of the triangle. Now, to find out the area of this triangle, we have a formula. We have a decent formula. Area of triangle ABC is given by half determinant of x1, x2, x3, y1, y2, y3, 1, 1, 1. So this is the formula to find out the area of the triangle. So if you simplify this down, you will get half of x1 y2 minus y3. You can see I'm just solving the determinant. x1 y2 minus y3 x1 into y2 minus y3 plus x2 into y3 minus y1, right? y3 minus y1 plus x3 into y2 minus y1, sorry, y1 minus y2, x3 is this y1 minus y2, okay, x3 into y1 minus y2. So this gives the area of the triangle. Okay, so now as we have seen how to find out the area of a triangle ABC, right? Now we'll see how to use this formula in a specific use case. Let's say we have 3 points A, B, and C which lie on a straight line. So these 3 points are collinear. The coordinates of these 3 points are x1, y1, x2, y2, and x3, y3 respectively. Now as these 3 points are collinear, that is they lie on a straight line, so these 3 points cannot form a triangle. So eventually the area of the triangle using these 3 points will be 0, will come out to be 0. That is half x1, x2, x3, y1, y2, y3, 1, 1, 1 will be 0. Now, if you have 3 points and you need to check for collinearity of these 3 points, that is, you have to check that A, B, C lie on a straight line or not, then you just put the coordinates in the triangle formula, and if the area of the triangle formed by those 3 points comes out to be 0, then these 3 points will lie on a straight line, right? These 3 points will be collinear. So this is a collinearity check. Okay, collinearity check. Now let's look at different standard points in a triangle. Okay, let's begin with centroid. Centroid is a point that passes through, that is present at the intersection of all the medians. So to understand centroid, we need to first understand what a median is. Okay, so a median is a line that starts from one of the corners and intersects the midpoint of the opposite side. So if P is the midpoint of BC, then AP is the median. Okay, similarly there will be 2 more medians, BQ. Q is the midpoint of AC, then BQ is a median, and then there is CR. Okay, CR is a median, where R is the midpoint of AB. Now the point of intersection of all these medians, that is G, let's call it as G. So this G is called as centroid. Very important fact about a centroid is that the centroid divides the median in the ratio. If BQ is for median, let's take BQ. The centroid will divide it in the ratio uh, 2:1. Okay, M to N. 2:1. Okay. Similarly, G will divide CR in the ratio 2:1. Okay, so this is from the corner. Okay, from the corner towards the other side, opposite side, 2:1. So this is a very important uh, fact about centroid. Then how to find out the centroid? If we say the coordinates are x1, y1, x2, y2, x3, y3 of the corners, then centroid is given as x1 plus 2 plus x3 by 3, y1 plus y2 plus y3 by 3. So this is the centroid of a triangle. Then another standard point in a triangle is circumcenter. Okay, circumcenter. Circumcenter is basically the center of the circle that encloses the triangle. That is, let me draw a triangle here. Okay, so this is a triangle, and let me draw a circle here. Oh, sorry. Let me draw a circle using this. Okay, here, here you go, like this. Okay, so this circle touches all the corners of the right. This circle touches all the corners. Okay, so this center of this circle that encloses the triangle and passes through each of the corners or vertices is known as circumcenter. This circle is known as circumcircle, and this center of this circumcircle is known as circumcenter. Let's say C. Uh, let me call it as M. Let's say M. Okay, circumcenter. Okay, so circumcenter is at equal distances from all the vertices. Okay, AM is equals to BM. As you can see, AM is the radius of the circumcircle, BM is also the radius of the circumcircle, CM is also the radius of the circumcircle. So AM is equals to BM is equals to CM. So this condition is used to find out the coordinates of the circumcircle. There is no specific formula to find out the circumcircle center. This condition is used to find out the circumcenter. Okay. Now the other important standard point in the circle is known as incentre. Incentre is the center of the circle that is enclosed by this triangle. Okay, that is inside the triangle. So let me draw here. As you can see. Okay, so incentre, what incentre does is it passes through all the midpoints. Okay, it passes through all the midpoints. Okay, it passes through all the midpoints. Okay, A, B, C. So this is known as incircle, and the center of this incircle is known as incentre. Let's notice that I incentre. This incentre is given as the coordinates are let's say if this is x1, y1. Okay, this is x2, y2. This is x3, y3. This distance AB is A, BC is B, AC is C. Then in-center coordinates are given by A x1 plus B x2 plus C x3 divided by A plus B plus C. A, B and C are the lengths of the sides AB, BC and AC respectively, comma AY1 plus BY2 plus CY3 divided by A plus B plus C. So this is how the coordinates of the in-center are found out. Okay, so these were the important standard points inside a circle. Okay, now there is one more point known as orthocentre. Okay, we draw the orthocentre. So orthocentre is basically the point where the altitudes intersect. Okay, so let me draw a triangle A, B, C, and altitude is nothing but the line that is starts from a vertex and is perpendicular to the opposite side. Starts from the vertex, perpendicular to the opposite side. Starts from the vertex and perpendicular to the opposite side. So the point where all altitudes meet is known as, let's denote as H. Sorry, H. This is known as orthocenter. Okay. Now, and there is no specific way to find out what an orthocenter is. You just need to remember that this is the orthocenter. Okay. One important point to note about orthocenter is that in a right angle triangle, okay, in a right angle triangle, there is an important finding which you need to remember, that in a right angle triangle, the orthocenter is the point where the right angle is formed. This is the orthocenter. Okay. Now let's see a question related to what we have studied till now. So in this question you can see a triangle with the vertices A, B and C is given, and we need to find out the circumcenter and the radius of the circumcircle. So as you know, we do not have a specific formula to find out the circumcenter. So there is one condition which is AM should be equal to BM should be equal to CA, right? So use this criteria to find out the coordinates of M. So let's say coordinates of M are x comma y. Okay. Then we need to find AM, BM and CM, and then we'll get two equations with by equating first AM with BM and then equating BM with CM. We'll solve these two equations to get the values of x and y. Let's see how. So first let's equate AM to BM. That is, AM is given by under root, let me write it here, x minus 2 the whole square plus y minus 1 the whole square, and BM is given by x minus 5 the whole square plus y minus 2 the whole square. Okay, now squaring both the sides, we'll get rid of the square roots and we'll be left with x minus 2 the whole square plus y minus 1 the whole square is equal to x minus 5 the whole square plus y minus 2 the whole square. Now we'll expand these terms inside the brackets. We'll get x square plus 4, 2 square is 4, okay, x square plus 4 minus 2 into 2 into x plus y square plus 1 minus 2 into 1 into y. This will be equal to x squared plus 25 5 squared minus 2 into 5 into x plus y squared plus 2 squared 4 minus 2 into 2 into x. Now as you can see, these terms, x squared will get cancelled out, y squared will get cancelled out. Now we are left with 4 minus 4x plus 1 minus 2y equal to minus 25 minus 10x plus 4 minus 4x, right? Now let's see, we'll take all the terms towards the in the right side. Okay. Okay, sorry, this is y. Okay, this is y2 into 2 into y, so this will be minus 4y. We'll take all the terms to the left hand side. We'll get 4 minus 4x plus 1 minus 2y minus 25 plus 10x minus 4 minus 4 plus 4y equals to 0. Now if you simplify this, you'll get 4 plus 1 5 minus 25 minus 20 minus 4 minus 24. You'll get minus 24. Then you'll add all the x terms. Minus 4x plus 10x 6x. You'll get plus 6x. Then you add all the y terms. Minus 2y plus 4y will get plus 2y equals to 0. This can be simplified to divide all the terms by 2. You'll get minus 12 plus 3x plus y equals 0. Then take the constant term towards the right hand side. You'll get 3x plus y equal to 12, right? So this is one equation. Let's call it as equation 1. Now the second equation can be found out by equating BM and CM. Let's see how. Okay, BM and CM. So you know BM is x minus 5 the whole squared plus y minus 2 the whole squared, and Cn is x minus 3 the whole squared plus y minus 4 the whole squared. So you can also write it as Bm squared is equal to Cn squared, just square it both the sides. So please simplify this. So Bm is x minus 5 the whole square plus y minus 2 the whole square, and Cm squared is x minus 3 the whole square plus y minus 4 the whole square, right? Now you can simplify this in the similar format and solve to get x square plus 25 minus 10x plus y square plus 4 minus 4y equals x square plus 9 minus 6x plus y square plus 16 minus 8x 8y. Okay, and if you simplify this in the similar fashion, you will arrive to an equation as x plus 3y equals to 10. Okay, this is the equation that you will get. Now you can solve equation 1 and 2 by substitution method, and you will get the value of solving 1 and 2. You'll get, let's put x equals to 10 by 10 minus 3y in 1. We'll get 3 into 10 minus 3y is equals plus y equal to 12. That is 30 minus 9y plus y equals to 12. We'll get minus 9y plus y is minus 8y equals to 12 minus 30. We'll get y equals to 12 minus 30 is minus 18 divided by 8. We'll get minus 8. Okay, minus minus will get cancelled. We'll get 2 9s or 2 4s, or we'll get 9 by 4. Now when you put y equals to 9 by 4 in any one of the equations 1 or 2, you will get x equal to, put y equals to 9 by 4 in 1, we'll get x as 13 by 4. Solving, you'll get x as 13 by 4. So the circumcentre is 13 by 4x and 9 by 4y. Okay, so this is the circumcentre. Now we know that the radius is equal to any one of these, right? AM, BM or CM. Okay, so let's find AM. Let's find AM. Okay, so An is x minus 2 the whole squared, x minus 2 the whole squared plus y minus 1 the whole square root. We'll get x is 13 by 4 minus 3 the whole square plus 9 by 4 minus 1 the whole square. On solving this, we'll get AM is equals to 5 root 2 by 4. Okay, so this is the radius of circumcentre. So this is how you deal with questions related to triangles using the concept of the Staines formula and the concept of the circumcentre, that the circumcentre is at an equidistant distance from all the corners. So these two concepts help you to find out the circumcentre as well as the radius of the circumcircle. Now let's look at one more question. So this question has been asked in IIT 2000. So let me phrase this question. This question is question 2. This question is the incentre of triangle with vertices 1 comma root 3, 0 comma 0 and 2 comma 0 is, and the options are A 1 comma root 3 by 2, B 2 by 3 comma 1 by root 3, C 2 by 3 comma root 3 by 2, and D 1 comma 1 by root 3. Alright, so we know that incentre of a triangle is given by a formula as incentre is equals to ax1 plus bx2 plus cx3 divided by a plus b plus c, comma ay1 plus by2 plus by3 divided by a plus b plus c. Now we have the values of x1, x2, x3, y1, y2, y3, but we do not have the values of a, b, c, which represent the length of the sides. So let me draw a figure to represent this triangle here. So if we draw here an axis system x, y, then one point is at 0, 0, the other point is at 2, 0, and the third point is at 1, root 3, right? So 1 is somewhere here, 1 and root 3 will be somewhere here, so 1, root 3, right? So join these 3 points with another color so it's visible. 1, 3, 0, 0 and 2, 0. Okay, we join these 3 points. Let's say this is A, this is B, this is C. Okay, and let's say this is x1, y1, this is x2, y2, this is x3, y3. Okay, fine. Now we need to find out AB, that is A, BC, that is B, and AC, that is C, small c. So AC is the most easiest to find out. AC will be straightforward, 2 minus 0 the whole square plus 0 minus 0 the whole square, that is 2 only, right? Now this AC is C. Now let's see how to find out A. So A is AB, that is under root 1 minus 0 the whole square plus root 3 minus 0 the whole square. That will be 1 plus root 3 the whole square is root 3 minus 0 is root 3 square is 3. So we will get 1 plus 3 is 4, square root of 4, that is 2, and we take only the positive value as distances are only positive, they are not negative. Then B will be found out as BC equal to 1 minus 2 the whole square plus root 3 minus 0 the whole square, right? So b comes out to be minus 1 the whole square is 1, root 3 the whole square is 3, so this will again come out to be root 4, that is 2. Okay, so all the sides are 2 of length 2. Now let's put it in the formula of incentre. We'll get 2x1 plus 2x2 plus 2x3 by 2 plus 2 plus 2, 2y1 plus 2y2 plus 2y3 by 2 plus 2 plus 2. Okay, so what is x1? x1 is 0, 2 into 0, plus 2 into x2 is 1, plus 2 into x3 is 2, by 2 plus 2 plus 2 is 2 plus 2, 4 plus 2, 6, 2 into y1 is 0, plus 2 into y2 is root 3, plus 2 into y3 is 0, 2 plus 2 plus 2 is 6, right? Now, this will turn out to be 0 plus 2 plus 4, that is 6, 2 plus 4 is 6, 0 plus 2 plus 4 by 6, this will come out to be 0 plus 2 root 3 plus 0 by 6, this will become 2 plus 4 is 6, 6 by 6 is 1, this will become 1 comma 2 root 3 by 6, let me write it 6 by 6, now this on simplification will be 1 comma root 3 by 3, and this again on simplification will give I equals to 1 comma root 3 can be written as root 3, 3 can be written as root 3 into root 3, so this will give root 3 will be cancelled, this will give 1 comma 1 by root 3, right? So the incentre is 1 comma 1 by root 3. Let's check it in the options. So if this is the correct option, option D is the correct answer.